Hello, my name is Xinrui Chen, and my net ID is XC856. This is question 2 for homework 3. The question is that X is uniform in the range of A to B and Y equals to X squared. Firstly, we need to find and draw the density function of X and the cumulative distribution function of X. Firstly, for the density function of X, when X in the range of A to B, it should equals to 1 over B minus A, and otherwise this density function should equals to 0. And we can draw this function. For the cumulative distribution function of X, when X smaller than A, it should be equals to 0. When X is in the range of A to B, it should be this cumulative distribution function should equals to 1 over B minus A times X plus 1. When B larger than X larger is greater and larger than B, the cumulative distribution function should equals to 1. You can find out here is 1. And this is cumulative distribution function. For question B, now, given that A equals to minus 1, B equals 3, we need to find and draw the density function of Y and the cumulative distribution function of Y. And we also need to find the exact value of Y. Firstly, for Y smaller than 0 and 1 greater than 9, the density function of Fy of Y is equals to 0. For Y is smaller, is greater and equals to 0 and smaller than 1, there should be 2 roots. Which is that X equals to plus minus square root y. We can first to draw the density function of x when a equals to -1 and b equals to 3, like this. And we can also try to draw the function of y equals to x squared. And we could find that the density function of y should equals to density function of x over the absolute value of gx1 its derivative. Plus the density plus the density function to the density function of x2 over the absolute value of the derivative of gx2, like this. And gx equals to is set to x squared, so that the derivative of gx should equals to plus minus 2 times square root of y. And then we can calculate the density function of y, which is equals to 1 over 4 times square root of y. For y in the range of 1 to 9, there is one root, which is that the density function of fy should equals to the density function of x over the absolute value of the derivative of gx, which is equals to 1 over 8 times square root of y, so that we can get the derivative, the density function of fy, which is when y in the range of 0 to 1, it should equals to 1 over 4 times square root y. When y is in the range of 1 to 9, it should equals to 1 over 8 times square root of y. Otherwise, the density function of y should equals to 0. And according to this, we could get the cumulative distribution function of y. When y is smaller than 0, it should equals to 0. When y in the range of 0 to 1, it should equals to 1/2 times square root of y. When y is in the range of 1 to 9, it should equals to 1/4 times square root of y plus 1. When y is greater and equals to 9, it should be equals to 1. So that the density function of y should equals to this. The cumulative distribution function should equals to this. And we can draw these two functions. After that, we need to calculate the exact value of y, which is equals to 1/4 times the integrate y times 1 over the square root of y from dy from 0 to 1 plus 1 over 8 times integrate it's not integrate, right? It is integrate, yeah. So plus 1 over 8 times integrate of y times 1 over square root of y from 1 to 9 here, like this. And we could get that the final answer should be equals to 7/3.